When working with radicals, we never want to have a radical in the denominator for our answer. In order to fix that, what you need to do is multiply both the top and the bottom by that same radical. In this case, it's going to be root 10 times by root 10. When you do that, that's actually going to cancel out the square root sign, and what you're left with is 10. You multiply the top, 1 times root 10, that's going to be root 10. In B, you have root 20 over 2 root 6. Now the key that we want to deal with right away is that root 6. We do not want that in our denominator. So you're going to multiply both the top and the bottom by root 6. Don't worry about the coefficient on the bottom. That's not the one we have to deal with. It's that root 6. So we have root 20 times by root 6. That's going to be root 120. On the bottom, you've got 2 times, of course, 6, because timesing that radicand by itself, you got rid of the square root sign. Okay, working this one out, root 120 can be reduced. That's the same as saying 4 times 30. That 4 is a perfect square. It can be brought out. So now this is 2 root 30 on the top. 2 times 6, well, that's going to be 12. 2 and 12, these can be reduced because they're both divisible by 2, so what you're going to be left with is root 30 over 6. That's your final answer. Next up we have root 18 over 5. This can be rewritten out as root 18 divided by root 5. In order to get rid of that root 5, you're going to times the top and the bottom by it. On the bottom, that's just going to be 5 now because that cancels out the square root sign. And you now, on the top, you've got 18 times 5. That's going to be root 90. 90 can be reduced because that's 9 times 10. 9 is a perfect square. It can be brought out. That's a 3. So now what you have here is 3 root 10 over 5. Can't reduce that any further, so that's going to be your final answer.